How do you see it? The graph represents the height h and the projectile after t seconds. So we have the picture here, and the ordinate represents the height, and the abscisses or x-axis represent the time in seconds. So now let's answer on those questions, but before that just let me take a pen here. So let me take a pen, okay. So now A says explain why h is a function of t. So it means f, the function, is equal with h of t. We wanted to verify why this is a function h of t. So let me write this way. So this is a function, h of t is a function because the h is a function of t, because if you do it here, for example, the vertical line test or a line test that is normal with the x-axis, every line is going to intersect just in one position, the graph of the function. If we are doing the vertical line test, how we call, or line test that is normal with the axis t. So in this case, or in other words, we can say this way: every point of t corresponds exactly to one point on the y-axis, or on the h in this case. So every point of t corresponds exactly to one point of the h. Therefore, A, it means that h is a function of t. And now if we go in a B says approximate the height of the projectile after 0.5 seconds. If we take 0.5 seconds and we go in a vertically here, it means is about 20. So if we take the coordinate is 0.5, and we look, for example, in what point it corresponds to the h, and the h is 20. And the other point is what we have to approximate is after 1.25 seconds. So 1 is here, but is in a half, is going to be something here. Is a 28 or is a little bit lower. And if I'm approximating here, is a little bit very hard. I can make a mistake because here is in a half. If we go in a half, if it looks to me like is a maximum, and maximum is looks like 0.28. If I'm going a little bit in between 1.25 is right here, is in the middle. So it's a 0.28, I would say. It's a 28 feet high, 27, 28, I don't know exactly, but it looks like it's there somewhere. 1.25, and with the eye it's very hard to, but approximately is 28 feet. In other words, between 1.0 and 1.5 is in the middle. If I'm going here, it's going to be maximum somewhere, and it's around between 25 and 30, but it's very near the 30, so it means it's around 28. And it says C says approximate the domain of h. If I'm approximating domain of the h, I see here I know is in the t-axis, but is from 0. 0 includes this point, is a closed point. So if this is a closed, I think we can use those a smaller or equal sign. And then if we are looking here at this point when intersect the t point, and here is a point 2.5 is right here, but the point is a little further than 2.5, so it's something like this. It means and one bar has a 0.5 and the other is here somewhere. It would be, for example, it looks to me is like just 1 point, 0.1 point further than 2.5, which means, according to how I see, is 2.6. The domain is from 0 to 2.6, and because it's the closed, I am using this smaller or equal. So in this interval is the time in seconds, the domain. So now we have t is a function of h. So it means it is f a function of t of h. Okay, let's see here. And the h is smaller. I am just writing, let's assume it is, but let's analyze first. But first of all, if, for example, we're doing the line test, and those lines that are normal or perpendicular to the h-axis, if we look in here, those are going to intercept the graph in two places, in more than one place, and graphically it says is not the t function of h, because not every point on the h corresponds exactly to one point of t, because as you see here, for example, this point here is in one place, and the other point here corresponds in two places. So the point of h corresponds in more than one, in one value of t. It means has two values. Therefore, this is not a function. And let's write with. Let me take some pen here, and this is not a function. So t is not a function of h.